lesson, we spoke about the circle basically, and inside the circle there are different words that we need to make sure that we're familiar with, and so this just gives you kind of an oversight of those words. Now, in the previous two lessons, we focused on facts or theorems that deal with the circle and the center. And so some of the theorems that we dealt with, probably the most popular one we dealt with, was that the angle at the center is twice the angle at the circumference. So the red one will be twice the size of the green one. So that was an important theorem. And then we also spoke about, this was towards the end of the last lesson, that if you have a chord and then you have a line from the center of the circle to that chord, and it goes to the midpoint of the chord, what do you know about that red line? That red line from the center, if you know it goes to the midpoint of the chord. What did we spoke about this briefly at the end of the last lesson. You can put your hand up or pop it in the chat. What do we know about that red line? So that red line, it already bisects the chord, yes, but the theorem actually is that if it goes to the midpoint, it will be at what? So a line from the center to the midpoint of a chord will always be at 90 degrees or perpendicular, yes. And then the other thing that we need to bear in mind about the center of the circle was if you have a chord, and it goes perpendicular from the center, then we know that it cuts this chord into two equal pieces. So that was something we mentioned. Well, maybe we didn't even mention it. Actually, maybe I didn't mention it in the last lesson, but you'll see it come up at the beginning of today. And then what else did I talk about? Was there anything else that I talked about? Angle at the center, angle. Oh, we spoke about that if you've got a diameter, what type of angle will the diameter always make at the circumference? Who can remember? So if you've got a diameter, you've got a line that goes through the middle, what will that angle always make at the circumference? Let's go to Bukle. Oh, did I mute you? Sorry, Bukle.
It will make a 90 degree.
90 degrees, yes, 90 degrees. Perfect. Okay, now there are some other ones, but for now we're just getting familiar with these shapes. So I'm focusing more on just understanding the basic shapes for now, but just to show you a little bit of the official reason. So the one theorem that we dealt with was line from center perpendicular to the chord. And then the other theorem was line from center to midpoint of the chord. So let's just see which one was which. So the green one was the line from center. It was this one over here. That was the green one. So line from center to midpoint of chord. And it allowed us to show that it was perpendicular. And then the other one would be line from center perpendicular to chord, which is that one there. Okay, let's see a question where these are used. So it says, in the diagram, O is the center of the circle. There is O. The diameter DE is perpendicular to the chord PQ. So the diameter DE is perpendicular to the chord PQ. Give me a thumbs up if you followed that so far. If all the words are sort of making sense and you're like, okay, I'm following this man on the screen. This is making sense so far. Give me a thumbs up in the chat. Give me a thumbs up in real life. Give me a thumbs, whatever thumbs you've got. I want to see them. If you followed me so far. I'm looking for thumbs. Where are my thumbs? Aha. Let the people use their thumbs. Okay, so now it says, we know that DE is 20 centimeters, and we know that CE is 2 centimeters. So let's maybe even put, so C is 2, and DE is this long diameter. It seems to be 20. Okay, so it seems to be 20. Now it says, after all that reading, calculate the length of the following using reasons. Find the value of OC. Now, where is OC in this drawing? OC is just this little bit over here. Would you agree? Now, tell me, how are we going to work out what OC is? Any ideas? So look at what we've got. We know that we have a diameter, which is 20. We know CE is 2, but how do we find the little red bit that was there? So OC is like this. There used to be a TV show called The OC, but I think most of you weren't even born yet. But any ideas? Let's just throw some ideas out there. What tips can you throw out there? Who can tell me the length of a radii? So, or a radius. You know the diameter. What is going to be the size of the radius in this question? What's going to be the size of the radius in this question? So if the diameter is 20, then I think the radius should be 20 over 2, which is 10. So if I look at this question, OE is just going to be 10. So what is OC going to be? What is OC going to be? So I know the picture is a little bit dramatic, but I think if OE is 10 and CE is 2, then OC must be 10 minus 2, which is 8 centimeters. So this bit over here, I know it looks weird, that must be 8 centimeters. Okay, so OC is 8 centimeters. Now, if I want to find out, so that's 8. It does look smaller, I know. It must have been a dodgy scale question there. Okay, we're almost done with this one. If I say to you, what is the size? Oh, why did we minus 2? Because at the very beginning, the question said that CE was 2. So it said that CE was 2 centimeters. And then what we did, let me actually get rid of all of this. So we know that DE is 20. So the bit in yellow is 10. Okay, that's OE. So OE is 10. Now, it then tells us that CE, the bit in blue, is 2. Now, it doesn't seem like it's a very good scale drawing, but if that's 2 and the whole thing is 10, then OC would need to be 8. Does that help, Naledi? Okay, now, I want to know, using the theorem that I mentioned earlier on, what do you think the length... Ooh, okay, this is going to be a bit tricky. I want to find the length over here of this one. But I don't have any connection to that right now. But do I know what this length over here is? my red dotted bit. What is that red dotted bit there? So I haven't got PC, the pink one yet, but I want to try and get it. But before I get it, does anybody know what the red dotted thing is? Callan has smashed it. Callan, why is OP equal to 10? Why is OP equal to 10? How did you know that? I think, yes. It's radii. Okay, now, we know this is 10. We know that even though this looks dodgy, OC is 8. How are we going to find the pink length using stuff that we've learned about in geometry before? Who has some ideas? What can you do? What type of triangle is this? What type of triangle is this? It's a Pythagorean triangle, yes. So I want you guys to use your knowledge of Pythagoras to help me find what PC is. So I'll give you some time, and then when you've worked it out, tell me in the chat. So using some of you know the Pythagorean theorem off by heart, but 10 squared equals 8 squared plus PC squared by Pythag. And then if I move these all across, I get that PC is 6 centimeters. Give me a thumbs up or a like an 8 out of 10 or like a 9 out of 9. Give me if you understood that, give me a like a 9 or an 8 or 10. If you didn't understand it, give me like a 3 or 2 or 1, just so I know kind of how people are feeling out there. Be honest so I know what speed to go at. Okay, now, if I wanted to know the length of this whole thing, so can you see I've got PC, but imagine I want PQ. PQ is a chord. What is the length of the chord PQ going to be? Now remember, you've worked out that the pink bit is 6. You've worked out that the pink bit is 6. Is there a theorem that deals with a line coming from the center perpendicular to a chord? The theorem says that if a line comes from the center perpendicular to the chord, those two parts are going to be equal. So what is the length of PQ going to be? So remember, for PQ, I'm going all the way from here across to there. And I think since that is 6, this will also have to be 6, which means that PQ will be 12 centimeters. And the reason would just be line from center perpendicular to chord. So because there was a line from the center perpendicular to the chord, it cuts it in half. And since I knew that was 6, this also had to be 6. So PQ is going to be 12 centimeters. All right. Now, this was just an example of the final type of question that relates to like the center of the circle, but I'm going to move on. The main topic for today is something called cyclic quads. If you found this little bit at the beginning tough, then don't forget to rewatch this as soon as the recording comes out. But it was just a little example of the theorems at work. So let us go to the following drawings. What I want to define for you is what a cyclic quad is. Today is going to be all about cyclic quads. So this is a, and then let me also just make sure that I am. Okay, cool. So basically, the two yellow ones are cyclic quads. The green one is not cyclic, and this one is not cyclic, right? And the reason is that the vertices Q are not on the circumference of the circle, and here the vertex T is actually inside the circle. So in order to be a cyclic quad, you need to have all four of your vertices on the circumference of a circle. Okay, so that is what a cyclic quad is. Now, once you have a cyclic quad, there are certain properties that you get for free. And I'll show you this in a moment. But basically, if you have a cyclic quad, the opposite angles will always add up to 180. They won't be the same necessarily, but the opposite angles will always add up to 180 is the one main idea we're going to look at now. And the other idea is if you have an exterior angle of a cyclic quad, then the exterior angle of the cyclic quad will be equal to the interior opposite angle of the cyclic quad. Visually, I could show it to you on this thing like that. So the exterior angle will be equal to the interior opposite, and opposite angles in a cyclic quad add up to 180. This is not the case with quadrilaterals that are not cyclic. Okay, let me show you a visualization of this so you can kind of see. I'm going to leave that one out. We'll do that in the next lesson. So if we go here, what you'll notice is that I can move this around, and you'll notice the red ones don't change, but the green ones do. But no matter what I do, they always add up to 180. So let me do this here. 97 plus 83 is 180. 71 plus 109 is 180. And so we can use this fact. The moment we can see something as a cyclic quad, we know that the opposite angles must add up to 180. So that theorem, you just write down opposite angles cyclic quad. And then the other theorem that deals with cyclic quads, that's okay, there's three of them. I'm going to do two of them tonight, is the exterior angle theorem. Right? So if we look at this one, you'll notice that I can move this point around. Let's even move this around. You'll notice that the two green ones, which are exterior angle and interior opposite, stay the same. So I move this around. The angles change, but the relationship holds constant. And so this will just be the shorthand reason that we use is exterior angle cyclic quad. So these are actually two quite relatively easy theorems. Let's see them in action in a question. So if you look at this question, I want you to find me angle X, and after finding angle X, I want you to find me angle Z, and then find me angle Y. And I want you to try and put the reasons that I mentioned so far if you can. Okay, over to you guys. And just say done in the chat when you're done. Okay. Just say done in the chat when you're done. Okay. So all we need to do in this case is, so X is going to be equal to 100 degrees, and the reason is going to be exterior angle cyclic quad. And then Z, you have a choice. You can either say that Z is 80 because of opposite angles cyclic quad, or you could also say Z is 80 because of angles on a straight line. Then the last one, what is Y going to be? Well, these are a pair of buddies, and together they must add up to 90. So Y must be 90. And so this will just be opposite angles cyclic quad. Okay. So that is and this is not other place in a test or an exam, but that's just using the properties of a cyclic quadrilateral. And the two most common ones are the exterior angle being equal to the interior opposite, and opposite angles adding up to 180. Okay, so we've got a basic question. Let's go for a more detailed one. Let me scroll up and find you a more detailed one. Let us go and have a look at question number 2 and 3. So I want you to find me the size of angle C and the size of angle D. And then in question 3, I want you to find me the size of angle X and find me the size of angle Y. Now you can see that these are cyclic quads. You don't have to prove anything. Proving something's a cyclic quad, we will cover at another time. But for now, we're just getting familiar with what a cyclic quad is. And I can visually see this is a cyclic quad. All 4 vertices are on the circumference. Now tell me what these angles are, and then we'll also put the reasons in. And just say done in the chat when you are done. Okay, so let us have a look at what is what. So C would be 101, and that would just be exterior angle cyclic quad. So this would be 101. And then D would be 180 minus 96, which would give me 84. And that will just be opposite angles cyclic quad as my reason. So that will be 84. And then over here, x will be 92, and this will just be exterior angle cyclic quad. So that will be 92. And then I'll come to you now, Rolani. I see your hand. What is y going to be? Y is just going to be 116 by the same reason. Okay, let's go to Rolani. What is your question, Rolani?
So I don't know if this is allowed. Can you say that C will be equal to the opposite exterior angle because it is almost every single time?
Can you say that C is equal to the opposite exterior angle? Is that what you said?
Yes, sir. The 101, because in the previous
Yeah, that's
question,
fine. It means the same thing. It means, I mean, the reason on the formula sheet is exterior angle cyclic quad, like that is, but what you've said is not wrong. I wouldn't deduct marks for that. But normally I just keep it as short
Okay.
as possible. Yeah. Okay, cool. Let us do some exercise. We've done some hard work, but we know that if we don't take care of our bodies, our brains go on strike. And so we need to make sure that we basically give our brain some chance to download the information that we've just acquired. And the best way I know of doing this from my experience in classes is to just relax my body for a bit. So let's start by just loosening up. Maybe give your arm a little shake. Give the other arm a little shake. You want to be nice, and it's hard to be, if you're loose and relaxed, it's hard for your brain to be stressed, even if it feels a bit silly at times. So shake out your legs. And then let's roll the shoulders nice and loosely back. So roll them back. And then you can roll them forwards. Okay. And put your arms out like this. Give them a little roll. Okay, then you can roll backwards. Always feels good. Okay. And then just give your arms one more shake. Nice and floppy. Like you're in a drama class or something where they're just doing like these relaxation exercises. And let's do some 3 deep breaths. So we're going to breathe in, and hold, and then breathe out. Breathe in. Breathe in. Okay, so you've got some oxygen. You told your brain that you don't need to be stressed. You can be nice and relaxed. And now what we're going to do is we're going to get some blood flow through our bodies. And the best way I know of doing this is jumping jacks, but always open to suggestions. And let's do 15 of them. So make sure everything around you is clear, that you're not going to whack anything. I know some of you might feel silly doing this, but I can promise you it does help with your concentration and resetting. Okay, 3, 2, 1, let's go. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Ooh, I definitely felt that. Oh, I ran the Two Oceans half marathon on the weekend and my legs are still recovering. Whoa. Okay. So let's do a little brain break, have a bit of fun. So here's the Maths 24 question. Can you make 24 using any of these cards on the chat? Who is going to be the Maths 24 champion for today? Let's do it, people. Let's do it. Rulani has got 5 times 3, 15 plus 3 plus 6, which is 24. Perfect. Very nicely done. Can anyone get the blue one? Rulani has claimed the red one. Okay, let's have a look. So 9854. Can anyone make oh, I think I know. I'm having a good Maths 24 day. If you go 9 minus 5, how can that help you get to 24? So if 9 minus 5 is 4, how would that help you get to 24? So that's 4. And then you go times 4, which is 16, plus 8 is 24. Okay, so I hope that your concentration feels like it's had a rest. We're going to get back to the questions that we're doing here. And I'm going to start with question 5 and 6. So a bit more detail. You are given that the exterior angle is 106, but you need to find the h that is hiding down here. I want you to give this a go. I'm open to suggestions or comments in the chat, or if you're feeling generous, what would you do first to try and find what h is? Atlachang, I agree. I would find angle A. What do you think angle A is going to be? I think angle A, or if I wanted to name it using the full thing, it's going to be bad, B-A-D, is going to be 106, and that's going to be exterior angle cyclic quad. So we know that this is 106, but we still haven't found h. So what do we have to do next? Or what other information could be helpful? What other information could be helpful? I do notice these two whiskers. Well, they're not really whiskers, but I think that means that I have an isosceles triangle. Yes. So Rolani has put the answer in the chat. If you go 180 minus 106, you're left with these two, but this one and this one have to be the same. So actually, to get the answer, it's just going to be 180 minus 106 divided by 2. And the reason you've used, there's two reasons you've used. The one is that the sum of angles in a triangle is 180. And you've also used the reason angles opposite equal sides. So you know that these two angles must be h. And so your final answer should be, what have we got? We've got 76 divided by 2. So you've got 37 degrees. Will it be the sum of angles in a triangle or opposite side equal angles? It will be both. So Atlechang, you've used both reasons because you've used to get this h over here, you use that these angles are opposite equal sides. But you've also used the fact that it's 180 to get this thing. So basically you used that bit and you used that bit to get you there. Okay, now, similar type of question. You are given, not the same, but similar. You are given angle C, which is hiding down here, and you need to find me the angle M that is chilling up here. And I'm open to suggestions in the chat if people are feeling generous, if they want to share some of their knowledge. All right, Atlechang is being very generous. Thank you, Atlechang. So if you look here, I think that angle E or DEC must equal 31 degrees. And that is again going to be the reason angles opposite equal sides. So the two equal sides are given, and you know that one must be the same. Well, actually the other way around. So this angle is opposite that side, and this angle is opposite this side. So that must be 31. Okay, now, what do we do next? It's useful, but it's no cigar yet. So you've got this is 31, you've got that's 31. Yes, you can get angle D. Angle D is going to be 180 minus 31 minus 31. And the reason is going to be sum of angles in triangle. So this is going to be, what's that? 62. So take away 120, we get 118. So what is going to be the size of angle M? What is going to be the size of angle M? Well, I actually realized that this is a cyclic quad. Look, here's the corners or the vertices. So M is an exterior angle, and its buddy is 118 over here. And so M is 118, and the reason is exterior angle cyclic quad. Yeah, perfect, 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 perfect. Give me a little bit of feedback. 10 if your understanding is nearly perfect with this. 0 if you feel like you have no understanding. 5 if you're somewhere in the middle. Let me know how you're feeling about these questions and understanding what I'm writing. It helps me decide how difficult to make the next question if you give me some feedback, and just be honest. Okay. It helps. The more honest you are, the better the questions will be. Okay. So let's go to question 7. And in question 7, you need to find the value of angle E for me. So that's this one over here. But you also need to find the value of angle F, which is over here. Now, if I look at this, alarm bells are going off in my head because I see the cyclic quad, right? So I know that these points make up a cyclic quad. But there's another shape that I feel like I've seen before, another theorem. What other theorem seems to be involved in this drawing? What other theorem seems to be involved in this drawing? Yeah, it's sort of what they call the arrowhead or theorem 3, or the angle at the center is twice the angle at the circumference. So that's going to come into it at some point. But first of all, find me the yellow one. Find me the yellow angle and tell me what that is. What do I get for that? I do notice these pair of friends here. I feel like the yellow and the blue get on quite well. If they come together, what do you think they're going to make? So I think that these two together, E plus 4E must equal 180. And that's because of opposite angles in a cyclic quad. Excuse my writing all over the place. But so 5E is 180. So what's E going to be? Well, E must be 180 divided by 5. Thanks, Stephen. You're right. 36. So E is going to be 36. What is the size of F going to be? What is the size of F going to be? So it just has to be double what E is. And the reason would be angle at center is twice angle at circumference. That's the reason on the official reason sheet. I will show you the official reasons sheet, I think, in the next lesson. I didn't want to overwhelm you with reasons at the beginning, but I think it is worth having a look at them as we get into this chapter. So, okay, well, you guys are doing pretty well, I think. So let's do another one. You are given this angle up here, which is 140, and you need to find for me the angle Y down here. But there are a couple of cool little lines here that are telling you things. So let's open it to the floor. In the chat, tell me, where would you go first? Or where would you start first for question 8? Where would you start first? Where is your brain saying, go there, go there? I'm not sure my brain is saying much at the moment. I do see a cyclic quad, so that must be kind of good news. But part of my brain, I don't know, it's not obvious where to go. It's like I could go down here, but part of me kind of wants to go there. Don't know if anybody else went there. Did anybody go to the red dot place like me? Yes, Rulani, I agree. I think we're in the same place there. So like this is 40. And where would you go from there? So angles on a straight line, yep. So we'll say that, let's see if I can squeeze this in on the end here. We'll say that CBD is 40 degrees, and that is going to be angles on a straight line. I think people are going to go for this over here. It's the same trick that we pulled earlier on, where we go D must be 180 minus 40 divided by 2, but we have to give 2 reasons. We have to give the reason the sum of angles in a triangle, and that we used for that 180 there. And then the other reason that we need to use is angles opposites equal sides. And that's why we knew we could divide by 2, because we know actually that these two angles are the same. Okay, so what is D? I get D is 70. Okay, are we ready to find what Y is now? What's Y going to be? Ooh, a nice kick in my neck there. Well, it feels like this one over here should be 140 to me. Well, it doesn't just feel, I actually know it. So then what does y have to be? Well, the only way that these two are going to be equal is if y is 70, and then I go exterior angle, cyclic quad. Could you lose the alternative angle as a reason? You can't Atlachang because there are no parallel lines here. The only time you would have been able to use alternate angles if you had these arrows indicating the lines were parallel, but there's no evidence to indicate they are parallel. So what I would say is that this has to be 140, therefore this has to be 70. Simtanda, let's go to you. Question.
So
Yeah.
so basically, is it also fine if we looked for angle E in order to find Y?
Yes. Okay. So that's another way of doing it. So did you say this is 70, therefore this is 110?
Yes.
Now that's interesting. So why is this question wrong? This question might be false because if you follow that logic, then this would have to be 35 and this would have to be 35. Now, oh, goodness gracious. Guys, I made a bit of a boo-boo because this isn't actually the exterior angle of the triangle, is it? So I made a bit of a mess up there. Can you all see that? If this angle is not the full exterior angle, so actually that would have been, what I did was wrong. There's just no ways around it. So let's reverse and see what we should have done. Thank you for picking that up, Siamtanda. So the trap that I fell into was I wasn't focusing enough to notice that this isn't actually the full exterior angle of the cyclic quad. It's just an angle. So all I know for sure is that's 40. I also know that this must be 70. And let me not use green, otherwise it gets confusing. So I'll rewrite this so I can work out everything that I did up to that point was awesome. But then I just made a colossal stuff up because I said that that was equal to that, and that was just wrong. So let's rewrite this. So we got that angle DBC is 40 degrees. And that was, oh, I had that already. So that's fine. Then I said that angle BCD is 70. And that was where I used the two reasons. And then we can say angle E is equal to 110 degrees. And that's going to be opposite angles cyclic quad. And then we can say that angle Y is equal to 180 minus 110 divided by 2, which is 35. And again, the reasons you're using there are sum of angles in a triangle. So that's for the 180. And then angles opposite equal sides. Thank you so much for spotting that, CM Tanda. Gold star for you. Okay, give me a little bit of feedback. Out of 10, give me a sense of your understanding of that question. 0 for nothing, 10 for perfect, 5 for somewhere in the middle. Let me know if you understood question 8 there. Okay. Sometimes when someone makes a mistake, you actually helps you understand even better. It's funny how that works, but it just seems like how our brains work. Okay. So let's do a little preview of the next lesson. So we dealt with two theorems that deal with cyclic quads, but there is another type of cyclic quad. Now, this cyclic quad is sometimes called this type of cyclic quad is sometimes called a butterfly for obvious reasons. And the way we get it is we start with all 4 points on the circumference, but then we join them across like that. Sorry, these should be straight lines, but I'm just drawing them. And this is also a theorem that deals with cyclic quads. But what's weird is in the butterfly, what you notice is that it doesn't matter where the wings end up going, but the angles will always be equal. So, this angle over here will be equal to that angle over there. And we call this theorem angles in the same segment. And the reason it's called that is if you imagine a chord or an arc going from here to here, this part down here is one segment, and then another segment is on this side. And if you took this chord or this arc and you made an angle at the circumference, and you then made another angle at the circumference, then these angles will be equal. But I'll save that for the next lesson. Basically, it is possible to have a cyclic quad that looks like a butterfly. And in that butterfly, the angles in sort of the top of the two wings will be equal. And we call this theorem angles in the same segment, or angles on the same arc. And that will be what we will talk about in the next lesson. All right,